All right. Hey, thanks for being here again. Got about a half an hour to talk about Apache Iceberg and TableFlow. Show of hands. Who is new to Iceberg looking for an introduction? Half. Okay. Who is fairly knowledgeable about Iceberg? Doesn't want to. Okay. So you good? Glad you're here. Bear with me. This is an introduction. So all of you who are looking for that, that's good. We're also going to talk about a Confluent thing called TableFlow, which is, I have said publicly, I think, this just sounds like I'm selling something, but I think it's the most original idea in analytics in 40 years. I'll tell you why, and you can argue with me in the comments. I want to set up some history because I think that's important, and I think to understand the scope of the kinds of things that are happening in data architecture and in application architecture these days, we have to look at history. Another thing we have to look at is our clicker. And we're just going to set that little guy down because it's not working. Before we get to that history, I don't want to bury the lead. Iceberg is a system, a format, a specification for imposing transactional semantics and table schemas, tabular schemas on data usually in a data lake. It is as if the data community is saying, we're very sorry for the whole ELT data lake thing where we said schema didn't matter and we'll figure it out later. It turns out schema always mattered and we learned it again. And that's what Iceberg is all about. Iceberg is a part of a category of technologies called open table formats. There are a few other competitors in that space, in the open source space. Iceberg at this point is really kind of the winner in the open source world, so it's the one we're talking about. Now, why is it big? And some history. So there's this gulf between the operational world and the analytical world. And it's joined by what is sometimes a rickety little bridge of batch processes copying data. Now, this originated, the word data warehouse, which all this comes from, the first book published on that topic is from 1992. Now, I was actually earning my living writing software in 1992. I was a college student, and I was writing embedded firmware. I had nothing to do with databases. I thought databases were for like engineers who couldn't hack it, which is kind of what a 20-year-old might think. Turns out not to have been true. But in that year, kind of the year I started writing software professionally, the first book was published called Building the Data Warehouse by a guy named Bill Inman. Bill Inman had been kind of carrying the banner for this idea, saying, hey guys, there's operational data and there's analytical data, and we got to treat them separately. They're not the same thing. And because of the technological limitations of the time, and because of so many really, really true considerations, he was very right. And he said, what we're going to do is we're going to take the operational data, pick it up, copy it, squish it around, because we have to transform it in various ways, dump it into this other database where we can then write reports. It wasn't dashboards then, it was reports. They got printed out on laser printers and handed to important people in the morning. And that was revolutionary, okay? That technology for letting you see everything in the business from the day before was huge. Because data, in the past 10 years, had been dispersed over the whole enterprise in dozens or hundreds of little databases instead of just one big mainframe. So it solved a real problem. It was very important, this divide between the operational and analytical data. And so, I got ahead of myself once again here, this data warehouse is a thing that we built in the 90s. And it paid very careful attention to schema, right? That was what it was all about. We had to look at the schema of the sources, transform them into this other schema, think carefully about modeling dimensions and facts and all this stuff, and build that giant data warehouse. It worked. Empires were built, fortunes, billions of dollars in enterprise software spend. It was just a great time for vendors and consultants and people who had data problems to solve. It worked until it didn't. In the late 2000s, the internet was not new. The internet as a mass market phenomenon was approaching 15 years old. But it wasn't until smartphones really happened, until the iPhone really happened, that ordinary people, not Yahoo, not eBay, not the internet giants of the day, but like normal programmers building stuff in companies, started to see data volumes that broke the previous data warehouse paradigm. It just didn't work anymore. And so Hadoop entered the scene. Hadoop had as an actual technology, you look back, really a short history. It kind of popped up and was super cool for about 15 minutes, and then gave birth to a whole bunch of other little products, projects, Zookeeper, Hive, Metastore, all these things that are just still around. Hadoop itself, dead. It really left its legacy to a thing called not the data warehouse, but the data lake. And this is where we get sort of the tradition that we're really receiving today. A lot of analytics are done this way. And the idea was, instead of, let's look carefully at the schema of all the things, model these transformations, create this other schema, conform dimensions, clean, remove null values, put it in a data warehouse, people like me 15 years ago were at meetups saying, no, bad idea, that's not going to work anymore. Forget about schema, just dump it in the lake, we'll figure it out later. And I personally never said that. It's just it would fall to somebody like me to do that kind of thing. And, we were doing our best, right? We're trying to solve problems. It was just wrong, though. It was really super duper wrong. It didn't work out. And so that often, in the next few years, that sort of became a dirty word. Data lakes were not really working out well. People started to call them swamps and talk about how gross they were and everything. Some people drifted off into more data warehouse technologies just in the cloud, and things like Snowflake came to life, or BigQuery. I always want to call BigQuery Bigtable, and that's just not the case. That's the underlying technology. So BigQuery became a thing where these are more sort of schema-oriented, more attention to data modeling. So there were a number of approaches. But along the way, in general, with the data lake tradition, we lost schema, really, and we lost the transactional semantics that we're used to having. It seemed like an okay trade at the time for the scale that we needed to get, but as I said, it really turned out not to be the case. And so in the late 2010s, technologies like Iceberg started to appear and attempt to reimpose responsible schema management and transactional semantics, basically make the database, the data lake, act like a database. Which is a reaction I get when I kind of explain Iceberg, attempt to explain it from the ground up. Some people say, it sounds like you're just building a database. And I say, well, yes, that's correct. And it's a strange way to walk into database architecture. I hope that sort of dawns on you. I'm about to show you how it works. And I hope it dawns on you that we really are just building a database, starting with the storage layer. That's not always where you'd start. If you just had a blank sheet of paper and you said, I need to build a database because there aren't enough of them, and what we need is one more. Number one, I definitely take a step back, ask some friends to kind of check in on you, maybe look in the mirror a little bit, maybe see a therapist. But here we are, and we're doing it starting at the storage layer, which is not normally where you'd start. We'll start with Parquet files. So a Parquet file, if you don't know, is a columnar file format. In other words, a file format optimized for analytics. So if you are making a database that's a transactional database, that means generally you are thinking about a thing. There's like an order, a row, a person, a train, a whatever, a thermostat. Usually transactional databases are concerned with a thing, and you create a thing, you update a thing, you read a thing. Typically, you're selecting small record sets, and it's that whole row that you care about. So you want to serialize that whole row. Usually with analytics, you want to try to figure out some group of rows to scan. There's a single measurement value that you need a bunch of them to scan in and compute some aggregation over. So you store those columns together, and that's what Parquet does. It's honestly worth checking out in some more detail than I'm giving you here. It's columnar and has this little nod to the fact that groups of rows are important too. It has a thing called row groups. So you get to make choices between how big you want your Parquet file to be and probably how many rows at a time you're going to want to scan. There's just some dials in the file format that let you set that. It also has metadata. The light blue is metadata stored in the file. So we're going to start here in the database. Start with this goofy file format. That's columnar, metadata is built in, we've got row groups, and it is, I regret to inform you, not yet a database. Okay, let's put the Parquet files somewhere. Let's put them in a bucket in the cloud blob store of your choice. And we'll just find a folder somewhere in there, and we'll put some Parquet files in here. This is sort of the early data lake, kind of how Hive worked. Say, well, there's a bunch of Parquet files in there somewhere, and they're very much like each other. They might all have the same schema. They might not quite. It's very scalable. I can make this as big as I want it. And about all you could say from there is that it's better than nothing, because this still is not a database. I might say, hey, look, everything in that directory, that's my table. I can add to it. I can maybe take things away from it. It's expensive to change, but I could call it a table. We're still not really there because we don't have any way of doing atomic updates. If I have a reader that's going through here and reading these files in this folder, and I'm busy creating or consolidating or something, the reader's just going to pick that stuff up. I can't do any kind of isolation between readers and writers. And the schema is just the fact that I've been disciplined and created Parquet files all the same kind, which, that's not going to happen, right? So still not a database. Because nobody is going to stop me from just freaking making a new file with a different schema and putting it in there. Or my own discipline is the only thing that'll stop me, and well, we don't want that. Okay, let's add something. Let's start building Iceberg a little piece at a time. I've got some Parquet files. A minute ago I said let's by convention put them all in the same directory. I'm going to relax that now. Maybe they will be, maybe they won't. I don't know. I've just got Parquet files. I know what their paths are. And I'm going to make, there is a typo here, and I'm fixing it. There. I'm going to make a JSON file that describes the data files that I want to be there. I'm just going to make a manifest for this group of files, rather than relying on them all being in the same place. And if I'm going to kind of keep tabs on these files, I might think I'm probably going to want a little bit of metadata. If there are some numeric columns, it's good to know the minimum and the maximum value. If there's date columns, I can be aware of things like that and say, well, here's the earliest and the latest date. Readers later on are going to want to know things like that to be able to prune files from a scan. So here we are. I've got some collection of Parquet files, and I got this JSON file that just kind of keeps tabs on them. And now I'm going to say that manifest file is my table. My table is not a directory that happens to have some files in it. I'll point to that manifest file and say that is my table. Now this starts to give me some things, right? Because I could always point to that one manifest file, and then if I want to change what the table looks like, I could be building those changes in some other Parquet files, maybe copying, transforming something, and then build another manifest file and flip over to that, right? So I'm starting to get some interesting functionality now that I've got that level of indirection. But there are some things I don't have as easily. Like I've got that one manifest file. What if I ingest some more? And I don't want to go through the process of consolidating anything. I've just ingested some more files, and I've got this one manifest file. I can only kind of ingest all at once, right? I have a hard time doing multiple ingest events. So let's add another file, the manifest list. The names of, we all know naming things is hard. The names of things in Iceberg are a little confusing your first time through. That's manifest file, and now we're going to have manifest list, which is a collection of manifest files. All right, it's also JSON, collection of manifest files, and information, so some more metadata that it's capturing at the manifest list level. So I've got Parquet files, manifest file, and other Parquet files, manifest file, and a manifest list. And now I'll point to that manifest list as what a table is. Rather than the manifest file, I'm saying, okay, I'm adding a layer. My table is actually what a manifest list is. And still, to accomplish atomicity, I'd have to do an awful lot of work here. I don't have a super organized way to do that. So let's add a couple more layers. The metadata file. So, manifest file, manifest list, metadata file, yet another JSON file, and it collects manifest files and these magical things called snapshots. And this is the end of our journey. This is what a table is. So now I have a manifest file. In that, it contains a thing called a snapshot. That snapshot points to a manifest list file. And I can have multiple snapshots in there that point to multiple manifest lists. This gives me everything I need for schema migration, for transactional inserts, upserts, isolation between reads and writes. It's all here. So let me just put it all on the screen, full structure of the thing. I've got Parquet files. I have various manifest files. Now, manifest files don't need to be exclusive. One can point to, or rather, I could have two manifest files pointing, or multiple manifest files pointing to a single Parquet file. That's fine and normal. I've got manifest lists. A manifest list can point to multiple manifest files. Then I've got the metadata file, which is the true definition of the table, and it can contain multiple snapshots. So that means we can travel through time now. The first ingest, whatever I do to create this table, I've got my Parquet files, I've got my manifest file, manifest list, metadata file, snapshot. That's there, right? And that snapshot will always, until I garbage collect it or expire it or delete it, that will always point to all those files. If I ingest more files, I can just add a manifest list or add a manifest file to a new manifest list that points to the new stuff and the old stuff and have a new snapshot point to that. So my metadata file just gains snapshots as my manifest list and manifest files and actual data files grow. And I've always got the old version. So if I want to read snapshot 0, point my query engine at snapshot 0, it can see exactly what was true when snapshot 0 was made. When I am in the middle of creating a new snapshot or doing whatever in the world I want, that's isolated from the old snapshot. If you have ever dug into the internals of Git, you should be thinking this looks very familiar because, well, it does. They're very similar. Git is very good at time travel and dealing with immutable data and tracking all these things. Iceberg works in a very similar way. And by the way, the Parquet files are immutable, so that's important in a moment. Finally, we'll add a catalog, and that catalog is a thing that maps table names to metadata file snapshots. So I'm not going to keep track of some path in Azure Blob Store to some JSON file and some snapshot UUID, because they're not nice little numbers like I have in the slide here. They're big, ugly numbers. We are not going to track those. We are going to say we would like the orders table because we're not animals. All right, we like nice names for things. And so the catalog is what translates that nice name into the ugly path and the ugly snapshot ID. Iceberg's not picky. And by the way, what is Iceberg? It's kind of an idea. It's kind of a specification. There's a reference implementation in Java, but that's just a reference implementation. You just have to obey the file formats, obey the semantics of the order in which operations have to take place in order to be Iceberg. You don't have to use some particular cloud service or even some particular collection of bits that call themselves Iceberg. I mean, obviously, the Apache project has a build and has code, but fundamentally, it's a specification, and that specification says the catalog can be anything you want. You can run SQLite on a Raspberry Pi if you would like and make that your catalog. It might have some scaling challenges, but it's not my system. You get to make your choices. AWS Glue, Hive Metastore, Nessie. Iceberg's got this thing called the REST catalog. That's a kind of a canned catalog. It could be lots of things. How are we on time? We're okay on time. Let's talk about the write path. Sure, we'll do it. How do we write into this thing? So broadly, we can divide this into the data layer, the metadata layer, and the catalog layer. And that makes sense. The metadata layer is these three layers of JSON files. Data layer is Parquet. Catalog is the catalog. I would like to introduce a component. I said Iceberg's an idea, it's a specification, and yeah, there's code, there's libraries, there's Spark libraries for doing things with Iceberg. There's all kinds of ways to make Iceberg happen, but fundamentally, like running a query on Iceberg, it doesn't do that. It doesn't do computation. It's this way of expressing tabular data in a data lake-like system in a way that's exposed to query engines that allows us to plug in the query engine of our choice. So now this allows innovation in the way we want to do queries across data lakes and potentially other kinds of data sources as well. So query engine, brand query engine, ask for it by name. It could be any of these things. A write comes in. We have to go ask the catalog, okay, for this table, what's the current metadata file? All right, we got the current metadata file now. We can go write some data files, write a manifest file that points to those data files, create a new manifest list, and write a new metadata file with the new snapshot. It looks something like that. That sequence of operations is a write. And this looks like a big ingest, right? We just created 4 gigabytes of Parquet. That was a lot in just a few animations. And then finally update the catalog to say the new snapshot is so-and-so. The read path looks a lot like it. Sort of blanking out the metadata layer and data layer. We're saying, okay, this is a new read. We don't know anything about what's going on there. Some read comes in. We'll go ask the catalog, well, where is the metadata file for this table? We'll get the metadata file, read that. We'll be able to chase down the manifest list, chase down the manifest file, and then we can find data files. Now, a good query engine, if this is not a full table scan, which would be an interesting thing in a data lake for a big table, but if there are like worthwhile predicates in here that we're filtering on, a good query engine will look at the metadata in the manifest list, in the manifest file, and say, I know some minimum and maximum values for some of these things, and looks like this column, I'm filtering on that, and the predicate is outside of that, so I can just prune certain of those Parquet files, never even look at them, right? Just optimize like that. And that's up to the query engine. It could be terrible and never do that, but it has the capability because the metadata is built in. I'm going to skip this because Peter said I really needed to keep the time. And there is, when we're changing data, because the data is immutable, we don't go to old Parquet files and edit them. When you're changing a row that's already in a Parquet file, doing an upsert, basically what you have to do is either take that old file, make a new copy of it with that row different, let's copy on write, or essentially mark the old row as deleted. Of course, there's a support for deleting. You create a file called a delete file, so that old row is deleted. I'm just going to make a new file with the updates. And that's not copy on write, but that's that is merge on read. Now, when it comes to compute engines, like I said, these can be pretty much anything. We have Spark, support for Spark, Flink. There are commercial options like Dremio, Databricks, Snowflake. Everybody wants to be on board with open table formats, and so you get to plug in things that you want there. Which gets us to a Confluent Cloud feature called TableFlow. So this is part of Confluent Cloud. It's part of a commercial offering, and I find it to be very interesting. So I like talking about it a little bit. Now that you see Iceberg and you see what Iceberg does, wouldn't it be cool if we could make a topic, a Kafka topic, look like an Iceberg table? So a Kafka topic, there's an API. I can produce to it. I can consume from it. All right. There are semantics about the ordering of messages and partitions and a retention period for how long messages are going to be available in that topic. And when I spin up a new consumer, I have the option of like rereading all the data, scanning all the data. All these things are true of Kafka. There's not much to Kafka. And that's like what it means to be Kafka, is to have that API and those semantics. And there are lots of Kafkas in the world that are not the tarball that you download from kafka.apache.org. You sort of have that API, have those semantics, and you are quote unquote Kafka these days, right? What's great about topics is that they are these massively scalable logs of immutable events. And representing history and the interactions between services as immutable events is an incredibly powerful abstraction that has proved itself over the past 14 years to have been incredibly successful. It's kicked off a whole new era in the way we write software and build data architectures. Very, very good idea, this log of immutable events. Also, they kind of suck to read. Okay, I like things that I can query. I like to ask questions. You know, what about all of the smart thermostats in zip code 80002? What about all of the houses that are hotter than 31 degrees Celsius right now? That's kind of hot for the inside. That's not a question you can ask a topic. You just go one event at a time, you scan them. That's awful. So we would like to be able to query. Now, traditionally, the way you do that in the analytics sense is you've got your Kafka cluster and you've got Kafka Connect and say some data lake. You want to get stuff off in the data lake. And so you have applications that are producing messages into the cluster, and then Connect reads them and writes them into the data lake, pulls them out of the topic and dumps them into the data lake, where we can then ask questions of them, right? This is sort of the Kafka brand of ETL. The operational data is here. Let's take it and let's move it to here. And this can be done with entirely responsible schema management, right? We don't have to do that sort of youthful rebellion thing where we act like schema doesn't matter. Doesn't have to be the case, but I'm still taking the data from there and putting it over to there. And that's okay. This works. It's in the data lake. I can ask it questions. Maybe that data lake is a Postgres database. If I want to do kind of more transactional type queries, I want to take the data from the topic and put it in the database. Happens all the time. It's also a slightly old paradigm. Old ways. That's a lot. You're not bad if you do this, okay? People do this all the time. Many, many good systems and architectures do it. But this operational and analytical estate that have been separated for literally generations now, that seems to be a problem. So let's see if we can come up with something a little more interesting. The way TableFlow works is I've got a topic over here on the left, and here's just some Iceberg data lake. I'm going to be producing messages to my topic for a little while till I hit some threshold. Don't mind those pulsating arrows over there. That's Keynote is just being excited. And after a little bit, I'm going to say, okay, I've got enough. I can dump a Parquet file. So let's do that. And what do we do when we write a Parquet file? Make a manifest file and a manifest list, and that manifest list can point to the old manifest file and just add on this new one, right? And I've got a new snapshot now. So under the covers here, that looks like a lot is going on. I could do it again, right? I'm happily producing. What does that mean to be producing? That means an application is doing work. A microservice is doing stuff and putting results in a topic. And application functionality is being satisfied, and a record of the history of the business is being kept in the topic. And instead of you having to say, well, okay, let me go get Kafka Connect and think about where this is going to go and do all this stuff, under the covers, all this cool stuff is happening where what it means to be Iceberg is being satisfied. And there's a lot of complexity there, but you don't see any of it. You have checked a little checkbox and said, yes, I would like this topic to be available as an Iceberg table. And, maybe my Kafka topic retention period is a very aggressive day or 2 days or something like that. I can keep the data for much longer in the Iceberg table. And it's exposed, the catalog is updated, whether that's a Confluent hosted catalog or a catalog in that's already running in Hive or somewhere in Unity catalog or whatever it is. That's updated. The table is there. The operational data, the analytical data are the same thing. And the thing that you see isn't this, and this is fun to know, right? You don't need to know any of this. What you need to know is, I got my operational data and I got my analytical data. That divide, that rickety little bridge is no longer a rickety little bridge. As far as you know, there isn't a divide at all. And that is, I think, pretty dang powerful. That's what TableFlow does. It's possible because of things like Iceberg. Prior to open table formats, this just wouldn't have made any sense at all. Now it's a thing that is here, it works, and in as much as it unifies the operational and analytical domains, I think it's the most original idea in analytics since 1992, maybe a little bit before then. Time will tell if that is an overstatement, but I'm saying it in public, saying it to the camera. So we will see. All right, if you want to check this out, take a picture of this QR code, try it, sign up, do it for free, you pay nothing. Put data in a Kafka topic. Use the data generator. Don't even put data in the topic. Just use the built-in data generator and make TableFlow happen. Thank you.